Hi and welcome. In this video, we will discuss about Arduino microcontroller and embedded programming. We know very well about embedded systems. It consists both hardware and software. So, especially I already told it is a hardware which is controlled by software. So actually the software is actually executed by a part called CPU, processor. So it is reacting, it is communicating with the atmosphere with the help of sensors and also executing some specific task with the help of actuators. It is already known to us. Now we comes into software part. Programming this hardware, this CPU is to be programmed properly. Whatever you need, what kind of automation if you want to provide, that kind of automation is only possible by means of a proper embedded program. So called the program, whatever we usually written for this kind of automation application is so called embedded programming. So in previous decade, the peoples working in embedded programming sectors, they usually write the codings in assembly language, and the device which is executing this program is a digital device. The CPU is a digital IC. So this is the hardware. So actually what it needs is a machine language. It need only zeros and one. As a program or as a command, it need only zeros and one. It only understands zeros and one. It is a digital IC, right? So it is machine language. This is so-called machine level language, a binary language. As a human being, we unable to process zeros and one. It is very difficult for us. We unable to follow a binary language for programming. So one step ahead we are thinking, and we are deciding writing the program in assembly language, which is nothing but hex code. We will speak in mnemonics like move A comma B, move B comma A. Likewise, we will tell there will be an assembler circuit. He will process the received command from the keyboard, and it will give the corresponding hex code. So this is so called assembly language program. So it is not either a higher level language or a lower level language. It is intermediate between both the higher level and lower level. It is a mid-level language. It is assembly language program. We need to assemble some of the predefined mnemonics. So in the subject called microprocessor and microcontroller, people usually studies instruction set, right? Move A comma B, add A comma B, move X at DPTR, move X at DPTR comma A. Likewise, these kind of instruction set, which belongs to 8085, 8086, 8051. So this is so called instruction sets. So each instruction is having their own mnemonics, like move A comma B. Okay, there will be a circuit called assembler. Assembler will bring you the corresponding hex code. Okay, if your hardware is not having assembler, forcefully you have to type the hex code for all the instructions. So you need to refer the data sheet, instruction sheet. Okay, so this is the usual procedure what the embedded peoples have been done with the previous embedded programming decades. This is quite difficult. So very difficult to teach, very difficult to learn. It is very time consuming process, and it is not understandable for all the peoples. So the embedded programming is vague. Once upon a time it was very vague, and it is very difficult to follow. Only the expert people can do these things, and there is a demand for this embedded programming. So the next level of thinking was done, that is higher level thinking, higher level language, writing everything in higher level language like Fortran, C, Java, Python, whatever the higher level language we know, that kind of higher level language. So higher level language is actually chosen. Its corresponding mnemonics will be automatically identified, and then it will be converted into machine language, and then finally the IC is now receiving zeros and one. This is the actual flow. Now the embedded programming is now the entire program as belongs to embedded system is doing. So whatever maybe the end device, I mean the device may be anything. It may be any kind of product, 8-bit, 4-bit. So whatever may be the final CPU IC, I will write the code in only higher level language. It will be converted into hex code. By the way, it will be converted into machine level code. So what I need is, I need only the hardware information, that's all. I need not to mug up anything like instruction set. So large numbers of nearly 200 or 300 instruction set will be there. So I need not to memorize those things. Just I will speak in my language. There will be a compiler between myself and the device itself. Those compiler will act as the assembler, as well as he is debugging my code, as well as it will convert the high level code into machine level code. This is the actual process which is going on now. So we usually prefer higher level language now. No need to go for assembly language. So this is the evaluation of controller IC. Yes, it was started from 4-bit, then 8-bit, 16-bit, 16-bit, 32-bit and 64-bit. So these are all the CPU's evaluation. So the controller ICs, its bit wide is getting increased. Now it is being in 64-bit, and obviously whenever the years passes, it was started from microprocessor, then microcontroller, PIC microcontroller, digital signal processor, ARM processor, ATmega controllers. Now it is commonly called as a processor. That's all. The speed of operation is getting differ, and I mean it is quite increasing day by day. So it is generally now it is called as a processor. Yeah, now it is getting a very big evaluation like this. It is started as IC. Now it is developed as a embedded board. As you can see, it is a Intel Galileo board. It is an embedded board. Okay, if you are having a 8051 or 8086 microprocessor or microcontroller IC, if you want to program it, it is very difficult to do that task, because you need a separate programmer kit. You need to just plug on this IC on that programmer kit with the help of a flash driver. Like it is a tiny software you have to install in your computer. With the help of the flash itself, you need to upload your code that is actually written in embedded C or some other language. If you have written your code, it is a difficult process, whatever the people follows, especially for this IC based embedded programming. Now it is converted into embedded boards. This is the second evaluation. Now it is very easy to plug with your computer. Just with the help of a data cable, you can able to plug in into your computer, and you have to install a specific software, I mean a interface software for this, and where you can write the program and you can simply dump the code into this embedded board. And also there will be a IO ports, dedicated IO ports for connecting sensors and actuators. Along with the embedded board itself, there will be a slots for IO devices. So it is not necessary to create a PCB platform or any dot board platform. We actually not need to have such kind of board arrangements. The IC comes with that board arrangements, and also some connecting sensors and actuators with this board is somewhat easy. And now we are having SoC based boards, system on chip. So in order to program this is belongs to NVIDIA Tegra K1 processor, and if you want to process this NVIDIA, you not need any host computer. I mean, you don't need any additional laptop or computer. This is a computer, this is a mini computer, that's all. It is having a OS. If you are connecting this board with a proper input output devices, like I am telling the commercial input output devices like keyboard, mouse, monitor, then if you are connecting the entire thing with the battery bank, the power source, you can able to easily program the device. You don't need any additional host computer. The SoC comes with the operating system. So these are all the evaluation of these embedded ICs. So initially it comes as IC, then it is a board, system on chip. Now we are using system on chip. So this video tells about Arduino. Arduino is nothing but an Italian product, an embedded board like this. It is similar to Intel Galileo. It is an embedded board. It is a beginner kit, and it is operated under 5 volt. So this is the USB plug. We can able to connect the USB A type of cable, a male cable, to this plug. Okay, this is female plug, and another end of the USB cable will be USB B type, and we can able to plug that another end to our computer or laptop. Now the device is getting powered through the USB cable itself. If you want to work the entire Arduino as a standalone system, you can able to connect the power supply from the battery to this connector. Now the board will work with the work by the power comes out from the battery. So this is the Arduino UNO board. This is so called UNO. It is having digital pins like this, and it is having analog pin like this. So you can able to connect analog sensors and digital sensors. Analog devices and digital devices. I am commonly calling devices because it either may be a sensors or actuators, right? So analog devices, we can able to connect A0 to A6. A0 to A5. There is 6 analog devices you can connect. Digital devices, it starts from 2 to 13. 0, 1, they are dedicated for serial communication. And this is Atmega 328 microcontroller. This is the actual microcontroller. The Arduino company is actually developing this entire Arduino UNO board. Actually, the master brain here is Atmega 328 microcontroller. It is a 8-bit microcontroller. And this is an onboard LED. This is a onboard LED. It is by default it is connected at pin number 13. And if you want to connect the sensors or actuators, generally if you want to connect any device to this board, this board is actually giving 5 volt and ground. Okay, in order to give power supply for the devices whatever you connect. So it need power supply, right? So that power supply it will be given by the Arduino itself. There will be a voltage regulator is there. So this voltage regulator will automatically receive the power from this battery connector or either USB controller, and it is actually giving the 5 volt ground or 3.3 volt as well as the ground signal here. So by the way, if you are connecting 2 or 3 sensors, you can able to give power from these terminals. And there will be a crystal oscillator here, and it is producing the pulses, and there will be a great reset switch, and there will be a power on LED here, and these are all the TX RX pins. If you are uploading the code from your laptop or computer to this Arduino board, you can able to see this TX is blinking, TX RX getting blinked. So these are all the major elements of Arduino UNO board. Actually, the Arduino is producing different varieties of embedded boards like this. So it is It may be mini, pro mini, nano, micro, fio, leonardo. This is the beginner kit what we visited before, ethernet, dew, and gamma, lilypad, usb, lilypad, zero, wi-fi, yun, mega, 101. So these are all different in sizes and different in specs. If you want to connect, they are different in price also. If you want to do some automations with the help of drone, okay, so possibly you need to use mini or nano, up to few you can use, because purposefully you have to reduce your size, right? The size of the microcontroller, the size of the entire drone must be reduced. So called the controller is also must be small in size, then only you can able to reduce the whole size of the drone, weight of the drone. So according to the application, we need to choose wisely the processor. And also in another side, if your application is in the need of connecting 20 different sensors, okay, obviously you unable to use right, because the is only possible, it is only providing 14 digital pins, but in my case I am having 20 different sensors, so I need to go for mega. So it comes with nearly 50 to 55 IO pins, so it is very easy to connect 20 different sensors. So according to our applications, what our application actually needs: size, power supply, number of sensors. So depends upon these factors, we can able to choose this Arduino device. So this Arduino can be connected with n number of sensors and n number of output actuators or activators, like temperature sensors, fire sensors, water level sensors, pressure sensors. So according to our application, we can connect different kind of sensors like this. Then we can able to connect different kind of actuators like relay, valve, a DC motor, solenoid, robotic control, or a timer. So everything we can able to set up like this. This is a node MCU, and there is a separate Wi-Fi module is available like ESP8266. There is a separate entity like ESP community. So it is collaborated along with Arduino, and there will be a new product called Node MCU. Now it is possible to connect Wi-Fi. This port can able to connect with the Wi-Fi, and you can upload your data to the cloud. So this is so called Node MCU ESP8266. So the Arduino, this is Node MCU, and this is operated under 3.3 volt, and this is 2.4 GHz and PCB antenna, and this is a flash button and reset button. This is micro USB, B type USB cable can be connected together, and this is the processor, Wi-Fi chip. These are all the pin details. Actually, the Arduino is C++ language. We write the code in C++ language. It will be converted into, during the compilation process, it will be converted into hex file, and it will be fetched into Arduino. So if you want to program the Arduino, there are two different steps. Go to the Arduino IDE. There is a software for Arduino, and write the program, debug and compile. It will check the syntax error or some other variable declaration or some kind of error. If there is any available errors or available, it will debug and report to you. It is a closed loop where you need to rewrite your program and give a correct program. It will be converted into either it will be a separate part for converting the file into hex. And if you want to do simulation, there is a specific software is available called ProTS. You can upload the hex file into ProTS, where you can able to virtually simulate the entire work. Okay, for example, a temperature sensor, Arduino, a fan. you can able to pick the elements from this Proteus library and connect the Arduino temperature sensor, fan, and just fetch the hex code, and you check the simulation whether it is working or not. You can do this kind of virtual simulation, and after confirming this hardware design as well as software, you can able to upload the code into Arduino board. There are two different methods, and I told right, this is the programmer kit where we need to insert our chip and we need to program with the help of this programmer kit. This is quite difficult before. Now this board like this comes with these USB controllers, the USB connectors. We can directly plug it on our computer. So this is the Arduino IDE. And this is the welcome screen. Whenever you open an Arduino IDE, it will show the welcome screen, a new Arduino code page like this. It is having void setup and void loop. Since it is a embedded programming, we need to intensively give the hardware details in this function, so-called void setup function. What kind of automation if you want to do, task to be performed, it should be deliberately given in this void loop function itself. So once at the hardware information to be given to be executed only one time, okay, the automation or the task to be performed, it should be continuously executed. So only the Arduino itself, the IDE itself, it is giving a command line like this. Kindly note, the command line should have \2 in front of it, right? So put your setup code here to run once. This is the command line given in the setup command. For programming the Arduino board, how many sensors I have connected, where I have connected, in which pin I have connected. This is the very useful information you have to initially tell to the Arduino program. So it should be given in setup command itself. Then loop command, it should be whatever the commands we need to run it continuously, so it should be available in this loop command. So put your main code here to run repeatedly, right? So it is look like a C++ code, and it is having some a proper syntax, and it is case sensitive. So a semicolon is mandatory for all the line in order to tell the termination, and a function should be properly opened with the help of curly braces, and it should be properly closed with the same curly braces. And this is the basic structure of an Arduino sketch. So this is the sample sketch for blinking an LED. So we know that there is a default 13th pin LED is available. So I am declaring that 13th pin number as a button, so it is integer. So I am declaring that on the top of all the commands. Above the setup command, it's a setup function itself, I am declaring. So the now variable button is globally declared. So inside the void setup itself, I am calling one API commands, pin mode button comma output. I am declaring the 13th pin as output pin. That's all. Then I am coming to loop command, digital write button comma high delay, digital write button comma low delay. So it is continuously executed 1 2 3 4, again 1 2 3 4. That's all. Until I remove the power supply from the board, it is continuously executed. That's all. So digital write button comma high, which means the 13th pin itself I need to connect LED. Right now it is defaultly connected. The Arduino comes with the 13th pin LED. But what I am telling is, if you want to connect some different sensors at the particular terminal itself, you have to connect physically. Here you are programming like this: digital write button comma high. Through the port itself you are sending high signal. Your delay 1000 milliseconds. Okay, within the delay command itself you are giving a number, right? Arduino will take it as a milliseconds, right? If you are giving 1000, Arduino will take it as 1000 milliseconds. That's all. So you have to understand that if you want to make 5 seconds of delay, don't put 5 here. Okay, delay of 5, Arduino will take it as a 5 milliseconds, so you have to give delay of 5000. So Arduino will understand 5000 milliseconds and will create 5 seconds delay, right? So 1 seconds, according to this program, after 1 seconds the digital write button comma low, the same pin number will give low, and again 1 second delay. So this process will repeated, so the LED at the 13th pin will blink with 1 seconds period of interval. This is the basic level. This is a layman example. All the usual embedded programming classes or all the tutorials will have this as a very first exercise. This is the very important exercise also. We can able to understand with the help of this program only, we can able to easily understand how to declare a pin number, how to send a data to the device, how to make the Arduino to make pass. So each and every information we can get from this